So we have a circuit here with 3 resistors and 3 ideal batteries, so they don't have a internal resistance. And we're given the 3 voltages for the batteries. So V1 is 13 volts, V2 is 7 volts, V3 is 4 volts. And we're trying to find the current in each of these resistors. It's a relatively straightforward problem. You just have to look at it with a different point of view. The first thing I'll do is I'll label some currents. I'll start here. Hold on a second. There we go. So I'll start with V2, and I'll assume that the current is going this way. I'll call it I 4 ohms because we're trying to find the current in each resistor. Now I'll label a second current for V3, more so, and I'll call it I3, moving this way. I'm not going to pay attention to the junctions for now. They're not that important. One of the problems with this specific question is that you just have way too many junctions all over the place, and so you don't know what's happening to all these currents here, 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 here. So that's why, just to keep the problem simple, I'm just focusing on labeling the specific currents I'll need to focus on, essentially. Now what I'll do is I'll start with doing a loop in this direction. I'll leave from battery V2, from the positive end of battery V2, and I'll do a loop this way, just ignoring the other loops and focusing on this bigger one here that I've just circled. And so now we're gonna have positive positive V2, and then current flows from high potential to low potential. So it's going to be final minus initial, and that's going to give us a negative answer. And we know that we have a 4 ohm resistor. V is equal to I. R is there. Ri is this. And now we're going through this battery V1. We don't need to care about what the current is here because we're just going through the battery and we're already given its voltage, so it's just positive 13 volts for V1. I'll write the equation first and then make it easier for you guys. So, and then after that we're pretty much done with the loop. We have gone through V2 and the 4 ohm resistor and this battery here. So that's good, we're done with one loop. And that is equal to 0. Basically, the loop rule says that the sum of the voltages of each component in a closed circuit is equal to 0. And that's what we're seeing here. Essentially, we have 2 positive voltages, and this is a negative voltage when we do the resistance of the resistor times the actual current itself. That's what the loop rule essentially what it is. So now I'm going to plug in the values. V2 was again 7 volts minus 4 ohms. That's ohms, by the way. I haven't written it clearly. Times the current in the 4 ohm resistor plus 13 volts, which is equal to 0. Now I'm just going to rearrange the equation. So that's going to be minus 20 volts here. And then I'll simply divide the negative 20 volts by, forgot the negative sign there, by the negative 4 ohms, and volts over ohms gives us amperes, so the current in the 4 ohm resistor is equal to 20 divided by 4, which I believe is 5. Yeah, so that's 5 amperes. So yeah, we got the right answer. That's 5 amperes. Nice. Now I'm going to erase all this. By the way, slightly off topic, but you can watch my videos on 2x speed. Sometimes my videos can be a bit longer. It's just because I try to like solve the problem while I'm thinking about it. So we now coming back to what we're actually doing. So we did that loop. That's awesome. Now I'm gonna erase a bit because it's way too messy. Now we'll go for this loop. We'll do this small loop. So essentially just this guy, this tiny square within the circle I just drew. We'll leave from battery V3, from the positive side of battery V3. So it's going to be positive V3. We'll go through and we'll go through the 3 ohm resistor. So we're going to have a negative sign. Why? Because current always flows from high potential to low potential. Basically, when the current is at this point, before going into the resistor, it's moving, in a way you could say it's moving faster. This is just an analogy, it doesn't actually make any sense, but it's moving faster. Once it's moved through the resistor, it's lost some energy, the current has lost some energy. So at this point, the current has less energy, whereas previously at that point, it had like more energy. So that's the idea here, why the potential would change. Essentially, you have less potential here in the current, whereas you have more here. Now then, hence, final minus initial, which of course gives us a negative answer, whatever it may be. So that's 3 ohms. Basically, V is equal to IR. So I got my resistance there, and now I have to just find that current in the 3 ohm resistor. Now we've basically gone through this entire loop. And why? Because with the only 2 components we had, I'm going to erase this stuff now. The only 2 components we had in this tiny loop were these 2 things that I've just circled. And that's it. So now coming back here, again, it's the loop rule. So, the sum of the voltages of each of the components in a closed loop are equal to 0. Hence now I'll plug in the values. So the voltage of V3 is 4 volts minus 3 ohms times the current in the 3 ohm resistor, which is equal to 0. Now I'll just rearrange and of course plug it into my calculator. So minus 4 volts divided by negative 3 ohms, and again that gives us amperes. That's 4 over 3 amperes, so that's the current in the 3 ohm resistor, and what do you know, we got it right. Awesome. Now I'm going to erase all of this as well. So we got the current in the 3 ohm resistor, and we have the current in the 4 ohm resistor. So we'll just put a tick here so I can remember, and we're going to find the current in the 2 ohm resistor, and I'm going to erase all that as well. Okay, so I'm just going to do a tiny loop here this way. So starting at V1, going down this way, and then going this way. Now, so V1, we're leaving from the positive end of the battery. So that's positive V1. And we're moving down this way. Originally, the current was actually going this way from the previous loop. So this is the current in the, I'll probably color it differently so you can understand it maybe. So the current that's going through here is in purple is actually the current in the 3 ohm resistor. But we're moving opposite to it, down this way in black, the black arrows. The current that we're trying to find is current in the 2 ohm resistor. Now what's happening here is that as we go down here, we're moving against the current of the 3 ohm resistor. So instead of having a negative sign, we have a positive sign. We're actually moving from, I'm gonna have to erase this a bit. We're actually moving from, this is actually high potential and this is actually low potential, because the current was originally moving this way. But since we're moving down, we're going from low potential to high potential. So when you do final minus initial here, you'll get a positive sign. Now I'm going to erase that because it's way too messy. That's awesome. So we've moved down here, and now we're going to move through the 2 ohm resistor. But first, let me put my values up there. So that's plus 3 ohms times the current in the 3 ohm resistor, which is 4/3 amperes. That's awesome. I'm going through the 2 ohm resistor. We're going from high potential to low potential, so that's going to be a negative sign. 2 ohms times the current in the 2 ohm resistor. Again, just to remind you guys, there's a lot of junctions here, and you have a lot of like breaking of the current, like the current just splits at so many junctions that it doesn't make any sense to try to think about, you know, what this current is or what that current is or what this current is and what that current is. You just want to focus on, like, for example, I'll erase all this. If you want to find the current in the 2 ohm resistor, you focus on that. Okay, I know that this area here is not the current in the 2 ohm resistor. It's the current in the 3 ohm resistor. That I know for sure. But when I get to here and here, this is the current. These two parts of this bigger circuit represent the current in the 2 ohm resistor. Yeah, I know that when the current of the 2 ohm resistor gets to this junction, it's gonna split or change again. So with this problem, you just need to focus more on specific pieces of a circuit and just knowing that, okay, I know that at least at these 2 points, at these two areas of a closed loop, the current is gonna be the current of the 2 ohm resistor, etc. So coming back to what I was saying, we're solving this loop that's equal to 0. V1 was 13 volts plus 3 times 4 over 3, which is just 4 volts, minus 2 ohms times the current in the 2 ohm resistor, which is equal to 0. Now I'm just gonna again rearrange simple math stuff. I don't think I need to show that, and plug it into my calculator. So that's minus 13, bring it on the other side, minus 4, that's minus 17, divided by negative 2. And that gives us 17 over 2 amperes, which is equal to 8.5 amperes. So what do you know? We also got that right, the current in the 2 ohm resistor. That's awesome. I hope this video helped you guys. And again, just to remind you, you can watch these videos on 2 times speed. Take care. Have a good day.